Here are your study guide solutions for your first trig test. So first, can you draw an angle? So to understand the angles, we need to know the compass that goes around these axes. So the angle straight up is 90, to the left is 180, to the bottom 270 and 360. We need to know the quadrant that this is in. So 330 is in between what two angles? And it's right here in quadrant number 4. And we're going to draw it so it's a little bit closer to 360. So we have our original ray, our terminal ray, that's at 330 approximately in the right quadrant. Then we start on the initial ray. Start here, not the slant, right here on the x-axis. And we go counterclockwise and rotate until we get to that terminal side. All right, 160 is in quadrant number 2, and it's a little closer to 180. So I'm going to draw that closer to 180. I'm also going to draw the initial side, and then I'm going to go counterclockwise and end there and draw my angle. Negative 250. So we need to understand our negative angles go clockwise. So negative 250, if I go clockwise, end up in quadrant number 2, a little bit closer to negative 270. And then we measure it clockwise, a rotation, to get there. Negative 110, again a negative angle, so we need to make sure that we go clockwise. So straight down is negative 90. So negative 110 is between here and quadrant 3, a little closer to negative 90. So I'm going to draw it closer to negative 90. And then again I'm going to go clockwise and rotate to draw that angle. 440, so that's bigger than 360. So we're going to understand that angles are rotations. So this is more than one rotation. So after one rotation, how much is left over? So we're going to subtract here and recognize 80 is left over. So 80 and 440 are coterminal. They share the same side. So 80 is in quadrant number 1, and it's a little bit closer to 90. So I'm going to draw it. So I'm drawing the angle like I'm drawing 80, but I know that I'm going to start at the initial side. I'm going to rotate counterclockwise, and I have to show one full rotation, and then I end there. So by rotating and continuing 80 more degrees, I show 440. So number 6, 610. Again, it's beyond 360, so I'm going to subtract and see what is left after you subtract 360, and then I need to know where 250 is. So if I go around the corners, I recognize 250 is here in quadrant number 3, a little bit closer to 270, and I recognize I'm going to have to rotate more than once. So I'm going to start on my initial side. I'm going to go counterclockwise. I'm going to rotate. So one rotation is 360. I continue to rotate, and then I end at that terminal side. And again, 250 and 610 are called coterminal. They share the same terminal side. All right, state what quadrant these are in. So for all of these, on the side here, I'm going to draw a set of axes and recognize and count 1, 2, 3, and then 4. And then I'm going to go 90, 180, 270, and 360. And then 25 is in which quadrant? It's in between what and what. So again, this at the beginning is also 0. So 25 is between 0 and 90. That's quadrant 1. 310 is between 270 and 360. That's quadrant 4. 125 is between 90 and 180. That's quadrant 2. 220 is in between 180 and 270. So that's quadrant 3. All right, find the reference angle. So to understand the reference angle, we're going to subtract either 180 or 360 from the angles, and then when it's radians, it's going to be pi or 2 pi. So for 205, to find the reference angle, the angle that's closer to 180, is it 205 closer to 180 or 360? And then we subtract. So 205 take away 180, and then get our answer. So that answer is 25 degrees. For 170, again, is 170 closer to 180 or closer to 360? Because it's closer to 180, I subtract from 180, always the larger number on top, and get our answer. That angle's 10 degrees. 330 is closer to 360. So I'm going to take 360 and subtract and get 30 degrees. Now, if it's in radians, then to find the reference angle, we're going to convert it first to make it easier. So to convert this first, we're going to multiply it times 180 over pi. That converts it to degrees. So the pi's cross out. So 3 goes into 180, 60 times 2. That's 120 degrees. And then which of these angles is closer, 360 or 180? And you can see it's 180. So I'm going to go 180 take away 120. And that means the reference angle here is 60. I'm going to do the same thing here underneath. So I'm going to go pi over 4 times 180 over pi to change it to degrees. So if I do the math, the pi's cross out. 180 divided by 4 is 45. Now the good news about 45 is that if it's in quadrant number 1, the angle I have is the angle for the reference angle. So 45 degrees. If the angle's already acute, if it's already between 0 and 90, that number, that is your reference angle. It's only when the angle is past 90 do we need to subtract 180 or 360. All right, 7 pi over 6. Again, we're going to change it to degrees by multiplying it by 180 over pi, cross them out, do the math, and it's 210 degrees. So how do I change 210 and understand the reference angle? So is 210 closer to 180 or closer to 360? So it's closer to 180, always the larger number on top, and then subtract, and you'll see the answer is 30 degrees as the reference angle. All right, turn the page. Convert into radians. We just did this, right? So to convert it, we're going to go 180 over pi and then use our calculator and multiply it out. It's 150. If it's in degrees, we multiply it by pi over 180, and then we can simplify it. This simplifies to 5 pi over 4. Again, we're going to multiply by either 180 over pi or pi over 180, meaning which way we're converting. For 5 pi over 3, what is that quadrant there? That is 300 degrees. 3 pi over 4, that's going to be 180 over pi again. That's 135 degrees. 60, so that's pi over 180 to change it to radians. When you reduce it down, that's pi over 3. And again, change it to radians, pi over 180, and then simplify it down, that's 3 pi over 2. So know when you're going 180 over pi or pi over 180, and then multiply it through and get your answer. All right, arc length. So we need to know the formula for arc length. So the letter we use for arc length is S, and it's just the radius times the degree in radians. And then we're going to round to the nearest tenth, so one number after the decimal. So to find the arc length, we take the radius, which is 12, and we multiply it times the degree, the central angle, in radians. So 5 pi over 3 is already in radians, so all we're doing is multiplying them together to find the arc length. So I'm going to open up Desmos. So you can press pause and do that. And so I'm going to go 12 times 5 pi over 3. And you get 62.8. So again, I want to find the arc length. So the radius is 11. The angle is in radians, pi over 2. You just multiply the radius times the angle. And again, we're going to use Desmos. That's 11 times pi over 2. That's 17.3. The radius again for the arc length is 15, and it's in radians. That's 5 pi over 6. If it was in degrees, you just have to go pi over 180 into the formula and you'd have the same answer. So 15 times 5 pi over 6 that gives you 39.3. If you look at the next question, the radius is 14 and the angle is pi over 2. That gives you the answer 21.999. If you round it, it's really 22. And if you have units, you should use the units. So this was inches, this should be meters. Here is kilometers, and here is centimeters. So make sure you include the units if units are there. What's the formula to find the area of a sector? And that's 1/2 r squared theta to the angle. So we're going to start with 1/2 the radius, and we're going to square it times the angle. And then type that into decimals. So you can either type in 1/2 or 0.5. And then 8 squared, and then 7 pi over 6. So that's 117.3. If you look at number 28, again, the formula would be 1/2 times the radius, which is 10 squared, times the angle, which is pi over 2. And you get the answer 78.5. For number 29, again, if you look at number 29, the radius, so it's 0.5. The formula is 1/2 times the radius squared times the angle, which is 3 pi over 2. And I'm also writing it down as I'm doing that. So I'm writing down what I'm writing down. So what I'm typing into the calculator, I'm writing that down first and then the answer. If you write down only the answer, you know you're not getting any credit. And again, we have units, right? So the first one should be feet squared for area. That's miles squared. This is still feet again, squared for area. So the last one here, it's 1/2 the radius squared times the angle in radians. Let's do that one more time. So 0.5 times 5 squared. Let's try it again. So 0.5 times 5 squared times 3 pi over 2. And you get 58.9. Done. Oh, and units, right? Meters squared. All right, turn the page. The next questions are trig ratio questions. So I need to know my trig ratio definitions. So one way to remember it is to write SOHCAHTOA. I know that cosecant is the reciprocal of sine. So the reciprocal here would be h over o. So I see the hypotenuse, and I also see the opposite side. So I actually don't need to find the missing side. The sides I need are there. So this is the opposite side. This is the hypotenuse. So it's hypotenuse over opposite, and you have your answer. Cosine is adjacent over hypotenuse. So from this angle, the adjacent side is right beside it, and the hypotenuse is the longest side. Again, I have the two sides I need. So the answer is 15 over 25. Secant is the reciprocal of cosine. So it's hypotenuse over adjacent. So I can see the hypotenuse is 4. The adjacent side is a. So I already have all the sides I need. So it's 4 over 3. Tangent, by definition, is opposite over adjacent. So from this angle, 6 is opposite, but 10 is the hypotenuse. So I'm actually missing this side here. So I'm going to call that A, and I'm going to use the Pythagorean theorem to set it up and to solve it. So if we need to, we can square it out and subtract. So 100 take away 36, and then square root it. And the square root of 64 is 8. That's the missing side. So now we have what we need. So opposite is 6, and the adjacent side is 8. Here, first the definition. From this angle, the adjacent side is 8, and the hypotenuse is 17. So the answer is just 8 over 17. So if the sides are there, we have a ratio. Sine is opposite, which we have, over hypotenuse, which we don't have. So this one I do need to use the Pythagorean theorem. So the setup to find this, we take those two legs and square them, is equal to the hypotenuse squared. We can use our calculator. I know the numbers are a little bit big. So we have 12 squared plus 16 squared. And then what is the square root of that number? So the square root of 400, that means the missing side is 20. Now I have all the sides that I need. So sine, again, is opposite over hypotenuse. So from here, the opposite side is 16, the hypotenuse is 20, and you have your answer. Cotangent. So that's the reciprocal of tangent. So I flip. Instead of O over A, you flip it. It's A over O. If I look here, I have my adjacent side and I have my opposite side. No, I don't. That's my hypotenuse. I don't have my opposite side. So I need to solve for it. So I'm going to go A squared plus B squared equals C squared, the Pythagorean theorem. I'm going to solve it. When you subtract 9 and square root, you can see the answer. So the answer that's missing is 4. So adjacent over hypotenuse would be 3, or adjacent over opposite would be 3 over 4. And you have your answer. Secant is the reciprocal of cosine. That's opposite, hypotenuse over adjacent. So from this angle, the hypotenuse is 13, and this is the adjacent side. I have both sides already. I don't need to use the Pythagorean theorem. That's 13 over 12. All right, turn the page. Next, can you find missing angles using trigonometry? So to find a missing angle using trigonometry, we're going to use sine, cosine, or tangent, just those three. So to find this angle, I'm going to circle it and recognize 14 is adjacent and hypotenuse is hypotenuse. Well, the 16 is the hypotenuse, and go which one of these is A and H, and see its cosine. To find a missing angle, we do the inverse, and then the ratio goes inside that inverse. And then I use either Desmos or your calculator to solve it. So if I go the inverse, so if I click on, first of all, if I go cosine and then the exponent button and -1, that will work, I think. And then if I go 14 over 16, you can see that the answer is an awkward decimal answer. If I click on the wrench and see how it's highlighted radians, I want degrees highlighted. So if we click on degrees and I do the work again, you can see that that now in degrees, if I round it to the nearest tenth, would be 28.95. It'd actually be 29 degrees. Okay, circle this. To find that angle theta, what ratio would I use? So 10 is opposite and the other 10 is adjacent. So which one uses opposite and adjacent? It's tangent. Whenever you find a missing angle, use the inverse and then those numbers. So opposite over adjacent, and then go to your calculator. So we're going to go inverse tangent. So I'm going to go tangent, then to the exponent -1, move the cursor, and then 10 over 10, and then you have your answer. So that angle is 45 degrees. Exactly. No irrational. It's a rational answer, 45 degrees. All right, find the measure of each side. So if I want to find the measure of each side, I'm going to circle the angle and label it. X is adjacent, and 14 is the hypotenuse. Which trig ratio uses A and H? So that's cosine. The angle is 59, and then I create a ratio on the other side. So adjacent is X, and the hypotenuse is 14. So I create X over 4, and then I'm going to solve it. So to get X by itself, the inverse of dividing is to multiply. So these cross out. So I'm going to multiply by 14. Cosine 59. So I'm going to use my calculator. 14 times cosine 59. And I get 7.2. All right, same thing. We're going to circle the angle. X is the opposite side and 8 is the hypotenuse. So which trig ratio uses opposite and hypotenuse? That's sine. Whenever we're finding a missing angle, we use the inverse of sine. And then our ratio goes inside. So opposite is, oh, we're not finding a missing angle, we're finding a missing side. So we're still using sine. So it's sine of 18 degrees equals, and then our ratio on the other side, which is X over 8. The inverse of dividing by 8, we're going to multiply by 8. And then this is what we type in the calculator, 8 sine 18. And that's 2.5 when you round. All right, look at number 43. What does it mean to solve a triangle? It means to find all the parts that are missing. So if I look here, I'm missing an angle, B. For that angle that's missing, I don't need trigonometry. I need to recognize that the two angles that are not 90 degrees add up to 90. So in other words, I just need to go 90 subtract 33, and that will give me the angle that's missing. So it all adds up to 180. So that angle is 57. To find the missing side, I'm going to label one X and one Y to find it. So this angle, 33, 6 is opposite. If I'm looking for X, that's adjacent, so that's tangent. So we write down tangent 33 and the ratio, which is 6 over X, and then you're going to solve it. So I'm going to multiply by X to begin with. Then I'm going to divide by tangent 33, and then use your calculator. So I'm going to type in 6 divided by tangent 33, and that gives me 9.2. I'm going to set up another equation to solve for the other missing side. So to solve for y, that's going to be opposite and hypotenuse. So that's sine. So I'm going to write down sine 33 is equal to opposite over hypotenuse. That would be 6 over y. And then I'm going to solve it. So I'm going to multiply by y. I'm going to divide by sine 33 and then use my calculator. So it's 6 divided by sine 33. And that is 11.0. All right, we're going to do the same thing here with 44. We're going to solve this triangle. So the easiest one to solve for is the missing angle, A. So I'm going to go 90, take away 23. That's going to give me 67. To find the missing side, x, that's opposite of 23 and hypotenuse, so that's sine 23. Create a ratio, x over 11, and then multiply by 11. That gets x by itself, and then use your calculator. So we're going to go 11 sine 23. That's 4.3. We're going to label the other side y. So for here, we know the adjacent side is what we're looking for over opposite or over hypotenuse. So adjacent and hypotenuse is cosine. So we go cosine 23, adjacent, which is y, over hypotenuse, which is 11. To get y by itself, the inverse of dividing is to multiply by 11. Now the y is by itself. Use your calculator. 11 cosine 23, and you get 10.1. All right, we did great work. So I'm going to do a second video that's question 45 on to the last page for the solutions. Mr. G Math, over and out. I hope that helped. I hope you did your best. You listened. Do it. Look it over again. Think with me. Don't just copy. Try to learn. And I hope it helped.